Hello students, welcome to this video, exercise 4, interval estimation. This video and this exercise will help you go through the computer assignment for this unit. So we're looking at these instructions and this Excel file here. Okay, the data is set to change all the time, which is what we want. So you go over to the side, press and hold delete. In an empty cell, you can see that the data is changing in yellow. That's what we want. We're going to, we want that because it's going to kind of really showcase the power of our sample size as we develop confidence intervals. So the first thing we want to do, step one, is we are in the data sheet. We are going to use the count, average, and standard deviation function to describe the data sets that we have for 1, 2, and 3. Data set 4, I don't have any values. I've just created different average and standard deviation to help us see some of the differences. So count function, highlighting all the data. We're going to do the functions for the first data set equals average, and then the standard deviation. There it is. You can see that the count is 10 for the first sample size. We can drag that across, and then we go from, the second one has a sample size of 30, and the third and fourth one have a sample size of 100. You can see the standard deviation all ranges between the same values. Averages are given there. So what we want to do now is construct a confidence interval using the t-distribution approach, because we do not know the population standard deviation. So we have to then base our confidence interval on the sample standard deviation, which is in row 108. So we're going to develop a 95% level of confidence. And what we're going to do is just go link that to the other cells, as I've done. So that if we change the first value, all of them change. We want it set to be 95%. The T alpha value we're going to use for step 2b is the TINV function. This will return to us the value that we would get if we had the t-distribution chart for us. So the probability is alpha, which is 1 minus a confidence interval, comma, the degrees of freedom, which is sample size, the count, minus 1. And we can see that, and we can just drag that across. I'm going to bring up the t-distribution chart. Because we have a value, when the confidence interval is 95%, we're getting a value of 2.262. And just to verify that that is the value we get on our chart, bring our chart over, 2.262, 95% confidence is this value here, that column, and there's 9 degrees of freedom, 2.262. When sample size was 30, we get a degrees of freedom of 2.29, so our t value would be 2.045, which is what we have in that spot there. So the next thing we want to do is calculate the standard error. Standard error is the standard deviation divided by the square root of the sample size. Square root is SQRT, sample size, and something happened, and there we go. Square root of our value. Margin of error is the standard error times the T alpha value here. So T times our margin of error, which is cell B112. Copy those and drag those across. We get the margin of error. Now note that the standard error and the margin of error decrease as our sample size increases. Sample size increasing from column B to column E, and we can see that the margin of error is decreasing. So of course, if we want a more accurate value, means basically means a larger sample size will give us that. The upper level is going to be the average plus the margin of error. The lower level is the average minus the margin of error. So we go equals average plus, that's cell number in 113, and the lower level, the average minus the margin of error. And we'll note that every time we hit enter, our values change. And doing that just to give us a better idea of the power of our sample size. So does it fall within the interval? Basically here we are on step 2F. Assume that the population average is 100. Does that value fall within the interval estimations? So when sample size was 10, we are estimating that the population average is going to be somewhere between 85.3 and 107.9. So does 100 fall within that? Yes, it does. However, every time we press a button, the delete button off over to the side, our values change. So what we're going to do is we're going to create an if function. It is one of the nice if and functions. So basically two logical tests have to be true for us to return the true value. So the if function is if bracket and bracket the upper level is greater than 100, comma the second part would be that the lower level is less than 100. If both of those are true, we're going to put a comma or a bracket at the end of that. If both of those are true, we want it to return yes. So put yes in quotation marks. If one of those values is not true, it's going to give us a no. So there's an if and function. And we can see that it's yes. So that means that 100 does fall within our confidence interval. We can see that 100 is higher than the lower level and lower than the upper level. So it does fall within that. It falls with all of them except for the last one. The last one we've developed a 95% confidence interval with for our data. And it gives us a lower level of 91.7, upper level of 97.9. So 100 does not fall within that. And if we go over to the side, press and hold delete, those first three values there in row 116 may change. It should change about 5% of the time. Oh, there it is. So just play around with that. Sometimes it will change. So we're going to leave the hypotheses testing section to the next video. So what I want to do now is go to the frequency sheet. Oh, before that, back in part 2, it says change the confidence level in row 110 to 99%. So change that. Look what happens to the margin of error. The margin of error is going to get bigger. We'll go over the side and we can see that the margin of error is quite a bit bigger now than it was when it was 95%. Our decision is still going to be the same based on the interval being including the value of 100. We can go back and change this to 90%, for example. Interval is much smaller. And there we go. Let's change it back to 95% in order to move forward here. So go to the frequency sheet. Frequency sheet, we have 3 columns of data. What we want to do is create a graph, a histogram for each one of those. So what we're going to do is highlight classes in that first column for n equals 10. Go into insert. There is our graph. We're going to make this a little smaller. Just push it over to the side for a second. We're going to do the same thing for the column C. So highlight column A, press and hold Control as you now highlight column C. Go into let go of Control, go into insert graph. There is our histogram for that one. Let's make this a little smaller, tuck it out of the way, and do the same thing for the third one. Highlight the first class, press our category or column, press Control. Highlight the second one, including the title n equals 100. Insert, and there is our graph for the third one. Let's make this a little smaller. Let's push all of them up here, because what we can see here is before we have to make these look like a histogram. So right click on one of the columns, format data series, change that gap width to 0. There's our histogram. Do the same thing for the other ones. And for our last one, just right click on any one of the columns, change the gap width, data format, data series, change the gap width to 0%. Let's get rid of that. Now what we can do is press and hold delete on a blank cell and observe what happens to the shape of the graph. And part C3, what graphs appear to look like a normal distribution. So you can look at this one. What graph changes most often is the one with the smaller sample size. The larger sample size, n equals 100, appears to be more normal more of the time. N equals 30, most of the time it looks like a normal distribution. N equals 10, hardly ever does it look like a normal distribution. So that's the power of the sample size. Larger sample size are going to appear more like a normal distribution than smaller sample sizes. So the last part of this is some type of just show and tell section. Let's go to the graph section here. Basically repeating the same thing we did with that frequency sheet. Just over here we can look at the 5 graphs, n equals 10, 30, 100, 500, and 1,000. So the data is set to change, so go into blank cell, press and hold delete. And you can just see that roughly the same thing. When the sample size is much smaller, very rarely does it appear normal. When sample size is much larger, like 1,000, it almost always appears normal. And that's, as I said, just the power of the sample size. So you can go and you can play with that. Press and hold delete, and it just changes like crazy times. And there's some general questions there to help you understand the relationship between the sample size and the shape of the distribution. Go to the intervals sheet here. Just a couple things I want to show here is I've created. We have our data. It's basically referring to the data back in the first sheet. Different sample sizes, different averages, and standard deviations. And I've developed confidence intervals for all of them at different levels, 90 to 99%. Blank cell, press and hold delete. And you can see that going across the intervals, the margin of error gets smaller with a greater sample size, and as we go from 19 to 99%, the margin of error gets bigger for all of them. Going down and going left to right, the margin of error gets smaller going left to right and bigger going top down. So you can hold that, and you can see that most of the time the average is going to be close to 100, but with that margin of error, it kind of gives us a greater confidence that we have included that population value. And we can play around with that. So that's the first exercise for our computer lab assignment in this unit.